Hi folks, this is my entry for the final project for our Coursera course. Before I get to the software, I like to go over the actual hardware that I wrote a simulator for. This is the Pioneer CDJ800 Mark II. It's pretty much a digital turntable. Allows to load CDs and maneuver with this huge jog wheel or platter. A couple of features that I've managed to implement, and I haven't implemented all of them, of course, is the pitch dial. This controls the tempo up and down. The play button, of course, cue button, and also some level of looping from cue in, cue out, and of course multiple tracks, so I can skip through the tracks I have in the application. So this is the actual 800 Mark II, and this is my final project. I'll zoom in. Before I get started, I'd like to say that all images are original. I've actually managed to take myself and cut in Photoshop. All right, so again, same platter, same visual HMI, human machine interface, and some of or subset of the functionality. So first of all, play the first track. So you'll notice the jog wheel is turning, which is actually different than the hardware, as well as the visualization that I've done on the right hand side. So if I pause it, the platter will stop playing, the visualization, the audio wave stops playing, and I can just continue on. While I do that, I can maneuver the pitch of the track, so I can slow it down. You'll notice the track wave has slowed down. You're getting a little bit more detail of the wave. That's why maybe the speed might not look like it's slowed down, but if you hear the audio and watch the actual wave, you'll notice they're synced in real time. You'll also notice the platter is slowed down in its spinning. So get it back to the original. And what I can do is I can press Q and go back to the beginning of the track. And then you also notice some additional textual information here at the top. This is the time code, which counts down and allows the DJ to know how much time he's got left, he or she has left. This is the beats per minute calculation. This is a little more accurate than the one presented in our class, which had a fixed wait time, which is not consistent between different type of tracks. What this calculation does takes a derivative of the audio wave and looks for the root, or when the derivative curve crosses the x-axis. And this calculation is also not very accurate, but more accurate than the one proposed in class or shown in class. All right. So what else we can do is I can pause the track. I can skim through the next track. You'll notice the next track is a little larger, so it's about 7 minutes long and 65 beats per minute. And of course, all copyrights belong to the authors of these tracks. They're both Daft Punk's Get Lucky under the Random Access album, but been remixed by other DJs. Okay, again, pitch. And this sets the cue put, sets the head point, but the API had some limitations. It looks like when you pass a time to the cue call, which is exactly what I'm doing in milliseconds. It wasn't working correctly. So the API had lots of limitations. I can't really do some of the features I like with the current API. For example, set the head tail, as the API refers to, the end of the track, so I could set a looping subset of the entire track. So I can set a different start point, a different end point, and allow the audio player to loop through that. So the API had some limitations there. The other limitation that the API had was this visualization, so I had to actually kind of manipulate around it. The reason I said earlier that you're getting a little more detailed, because actually in order to make it real time as possible, I incorporated a frame rate time, which in this system is about 10 frames per second, and that gets rolled into this wave, and this wave's height is actually dependent on the number of pixels available for this window, which is not the same of my timer skipping through the audio data. It's a little the actual height, pixel height, is less than the skips, like the indexing that goes along with the actual audio data. All right, I hope you enjoyed my submission, and thanks for checking it out.